Okay, 5.4 and 5.5 comes from two sections. It's mostly a review of stuff we've already done all term. We're just adding in a new graph, which is not hard. It's not hard. Easy. Easy, easy, easy. Compared to these graphs we've been doing, this is a piece of cake. Okay, families of functions. The new graph is called absolute value. Does anyone know what an absolute value function already looks like? Well, okay, the absolute value sign as the bars. The absolute value function, we'll discover today what it looks like. The graph, what the graph looks like. You got it. So, essential question. How are the transformations and translations similar and different between the following functions? Between linear, quadratic, and absolute value functions. Okay, I'll move my head shortly. How are the translations, similar or different between linear, quadratic, and absolute value functions? Okay, translation is a fancy math word for shift. We've talked about shifts for months, right? Horizontal shifts, vertical shifts. I do not swear if you think that's what I just did. Shift. S-H-I-F-T. Yes, there's some common letters in there with another word, but shift. Okay. Yeah, okay. I don't talk like that. Transformations is our multiplier. That A, remember how it affects the arms of the graph? Transformations is what the A does to the graph. Translations are the shifts. I can't say it now. Shifts. Shifts. Horizontally and vertically. Okay? But first, let's learn what our new function looks like. An absolute value function. The parent function, as all functions you'll be learning this year and next year have. A parent function is the most basic function that has an absolute value, which would be y equals absolute value x. No extra frill on it. No horizontal shifts or vertical shifts on it. Make sure your absolute value bars are long and tall, because you don't want to confuse them by being ones or L's. Okay, so we have the same properties that all of our other functions have. We have x minus h plus k. What do you think the A does to the graph? Could make it steeper. When will it become steeper? When absolute value of A is, we have to go up more than we go out. What type of numbers are go? Well, absolute value will make it positive. Okay, what type? Give me a fraction, a ratio that has a higher numerator. 7 over 2, which is the number 3.5, because we'll be going up 3, out 2, up 3, out 2, up 3, out 2. Okay, so any numbers greater than 3.5 is greater than 1, right? Also, the number 2 would have worked, because 2 over 1 is its ratio, up 2 over 1, up 2. As long as we're going up or down more than we're going out, that is a vertical stretch. The vertical stretch makes the graph steeper. The arms go in because we're going up more than we're going out. So we're going up. If it was 3/5, we'd be going up 3.5 times as fast as the parent function. When do we get a vertical compression? Not necessarily less than 0. When a is between two numbers. 0 and 1. When it's a fraction, it could be a decimal as well, but generally we write it as a fraction. Between 0 and 1, it's a vertical compression, which gets it wider, flattens out the arms. Okay, like the fraction 1/5. If I go up 1, out 5, up 1, out 5, I'm going wider, way more than I'm going up. And the last one, some of you said, what happens if a is less than 0? What type of numbers are less than 0? Negative. And if our graph is negative, it flips, yeah? Down. Okay, Deepika, what does the H do to the graph? Also starts with an H. Horizontal shift. So that's a translation. If you see the word translation, it's talking about a shift. Okay? And what does the K do to the graph, Gilberto? What does the K do? If the H is horizontal shift, then the K would be the vertical shift. Good. And our saying is the same. What goes with the H? Opposite, same. Okay? So the only difference is instead of parentheses and a square, we have an absolute value sign. Okay, so let's see what this graph looks like. Let's get some values here. First, the parent function, where's its vertex? What's the opposite of the number being added or subtracted to the x? What number is in here with the x? Being added or subtracted to the x? 0. What number's out here? 0. So the center, or the vertex, is 0, 0. We need a couple smaller, -1, -2 or smaller, and a couple bigger to see what the graph looks like. And we plug them in. For our work, what is the absolute value of -2? Positive 2, yep. The absolute value means the distance from 0. Yeah?
Do we have to write down the work like that? If it's just the parent function?
No. This one's easy to do in your head. Others, yes, because it's a little more difficult. Okay, what's the absolute value of -1? 1, because the distance from 0, -1, is 1 unit away from 0. What's the absolute value of +1? This is where you have to do the absolute value bars really long and tall, because otherwise it looks like 111. It's not 111. Okay, and lastly, what's the absolute value of 2? 2. Do you notice anything that we've seen before with the quadratics? Starts with an S. Symmetry around the vertex. Okay, take the edge of your calculator and draw yourself a grid. Coordinate plane. None of our y's are negative. So we only need the t, upside down t. 1, 2, 1, 2. It's like we're just going from 1 to 2. Label everything. We're trying to find out what shape this graph takes. -2, 2, -1, 1, 0, 0. Then we have symmetry. Interesting. Jennifer, what shape does this take? V shape. So the quadratic is a U, Because the slope is always changing on the quadratic. But the absolute value, notice the value has a v in it, has a constant slope going down, and then a constant slope going up. Each of the arms are linear. One has a negative slope and one has a positive slope because there's two pieces. So absolute value graph has a v. Looks like a v function. Good. Okay, so I'm going to give you a graph, and I want you to write the equation of the function. Given the graph, write the function. Let's do, I'll put the points here so you can plot it right. 3, 4. 4, 2, and 2, 2. We're going to write the equation of this function. Given the graph, we have points 3, 4, 2, 2, and 4, 2. If you can see the vertex, you actually know most of the equation. You can see the vertex, you just go opposite, same. The tricky part sometimes is finding the A. Turn to your neighbor, please, and tell them the vertex, and then describe how would you plug it into this function. Turn to your neighbor, tell them what the vertex is, and describe how you would plug it in to our A, H, and K. Don't just say no idea. It's the same thing had it been a quadratic. Okay. Felipe, what is the vertex? 3, 4. Yep. Okay, someone else. Felipe, choose someone. How are we going to plug this in? Who are you picking on? Kevin? Kevin, how do we plug in 3, 4 into our function here? And they stay 3 and 4? So instead of plus 3, we would write, yeah. So where the H is, we put -3 because that should be opposite. This one was opposite, this one was same. So it's just like quadratics. We've done this before. The A, though, is our slope. And absolute values have a consistent linear slope. How many from the vertex? How many do I go down? So what number is that? -2 over how many do I run? So the -2 over 1, which is just -2. So that is the function. It's pretty much the same as quadratics. In a minute. I'm going to give you a couple functions, and then you have to turn to your neighbor in 4 words, tell them how the function changes from the parent function. Describe, this is called a translation. Describe the translation. Translation is a fancy word for shift. There's an F in there too. I'll do just one first. We'll label this 2 part A. Okay, y equals the absolute value of x minus 8. In 4 words, turn to your neighbor, please, and tell them what happens to the graph compared to the parent function. 4 words. We've done this before. It's the same with quadratics. A translation is a shift. So we're either talking about a horizontal shift or a vertical shift. And which direction and how many units? Find a partner? Brandon, did you find a partner back there? Who? Casper? Okay, who thinks your neighbor knew what they were talking about? Okay, Derek, what did your neighbor say? Is that 4 words, though? I need 4 words. Who has a partner that had 4 words that you think they know what they're talking about? Daniela? 2, right? Yeah. Horizontal shift because it's inside, right? Horizontal shift is inside. Vertical shift is outside. But since it says minus, we do opposite. So we go right 8. Okay, you guys get a 60-second break and then come back. Please be quiet in the hall. Hurry, go get a drink. It's only been 17 minutes. Okay, I'm going to give you another one. Come back in, grab your seat. And again, in 4 words, you are going to have to be able to come up with a description of the translation. Y equals x plus 5. In 4 words, you should be able to describe the translation.
Your horizontal shift can be made into like 1 word.
No, it's 2 words. Okay, turn to your neighbor. Give them the 4 words. This one's sounding much better already. Okay. Who wants to call on Karin? Okay, Karin. Thumbs up or thumbs down? Yes? Or we need to pick something? Vertical shift up 5? I think so. Because this one should be same. Good job, Karin. Karin, I'll let you pick on someone after I write this. So, if you look like you're not working or don't know what you're doing, then maybe Karin will pick you. Okay, describing the transformations and translations.
Does this have to be 4 words?
This one, whoa ladies, hustle in. This one has 8 words for 2 pieces combined, and this one's a long one. 4 words for the 3, 4 words for the -4, and a bunch of words for the -2. Okay? Come up with it with your partner. Make sure you look like you're working or Karin's going to pick on you. Make sure you know what you're doing. Caitlin X, turn to one of these ladies next to you and work with them. 4 words for the 3, 4 words for the -4, and a bunch of words for the -2. A bunch. I could do it probably in, well, 8 words for the -2. If I described everything that the -2 would do. The -2 would be the only part that you might be a little hazy on, but you should definitely get the 4 words for the 3 and the 4 words for the -4. It's not that, because is absolute value of that greater than 1 or between 0 and 1? Well, I was going to do this, definitely. What's the absolute value of -2? How far away from 0 is -2? 2. So is 2 greater than 1 or between 0 and 1? Yeah, so it'd be a vertical stretch. Okay, Karen. Pick someone to tell me what the 3 and the -4 does. We'll be lenient about the -2 for a minute. Dan, in 4 words, what does the 3 do?
Oh, the 3. It's a horizontal shift.
Thumbs up or thumbs down? What do you think? It says plus. Are we supposed to go left if it's plus? Yeah, for the horizontal shift. We do opposite. Okay, Dan, -4. What does that do?
Vertical shift down.
Thumbs up or thumbs down? He said vertical shift down 4. That looks good to me because that is same. All right. Dan, do you know what the -2 does to the graph? That's one thing. Flips. And no, you don't flip left and right. It just flips. Tatiana? I don't think it's a compression because the absolute value of -2 is +2. Is 2 between 0 and 1, or is it greater than 1? Whoops. Greater than 1 or between 0 and 1? It's greater than 1. Absolute value of -2 is +2, which is greater than 1. So it's a vertical stretch, and we say by a factor of 2. By a factor of 2. And if you put by a factor of -2, it would be the same. Stretch by a factor of 2. All that good stuff describes the translations, which are the 2 shifts, and the transformation is the flip and the vertical stretch by a factor of 2. Those are transformations. Okay, so lastly, I'm going to give you basically reverse of this. I'm going to give you these details, and I'm going to ask you to apply them to both the linear, all 3, linear, quadratic, and absolute value. I'm like, what's our new one? Absolute value. Okay, that's the last part of notes, and we're done. Yeah. We're almost halfway through your 10th grade year. 2.5 more years and you graduate and go to college. Woo. Ah, yes. Thank you. Okay. Given the horizontal shifts, or formations and translations, write the equation of the linear, quadratic, and absolute value functions. Quadratic and absolute value. Okay, if I gave you a horizontal shift left, what number should we use? 7. And a vertical compression by a factor of, oh, do you know what a compression looks like? Right, by a factor, but what type of numbers? So I need a fraction. What's our fraction? 2/9, sure. Okay, please write the linear equation using those, the quadratic equation using those, and the absolute value. So you'll have 3 different functions that have been transformed and translated. Transformation is what the A does to the graph. Translation is the shift. That's all you need to do. Write the equation that includes a horizontal shift left 7 and a vertical compression by a factor of 2/9. 2/9, yeah. Sorry, I started changing it midway. Yeah, 2/9. All you have to do is insert A, H, and K. Right, Dan, would you pick someone to go up and write the quadratic? Let's start with that one. I think we'll do linear last. That shows a horizontal shift left 7. It's like punching someone.
Hey, Cassandra. Oh, Tony, I choose you.
Who wants to volunteer for tribute?
Oh, just that. I choose you, Carl. Excuse you.
Oh, guys, come on.
All right, I'll do it.
Oh, Rekka wants to do it. Rekka volunteers for tribute. Well, go write it up on the board, Rekka. Let's see if it's right or wrong. For quadratic. Oh, can you do it on the smartboard? Thanks. In the middle section for the quadratic. Thumbs up, thumbs down. What do you think? She wants to know if it's right or wrong. I think it is right. Isn't vertical compression by a factor of 2/9? That's your multiplier A? So she multiplied it. And why did she put plus 7 even though it said left? Opposite. Good job, Rekka. Now that you've seen how it's done, anyone volunteer to do absolute value? Okay, you're up. Thanks. Because that one was a quadratic. Quadratic is square. Very similar. Very similar for linear. All 3 of these have common characteristics. Okay, for absolute value, what do you think? Thumbs up, thumbs down. Yay, nay. Yeah, I think it's good. 2/9 times the absolute value, x plus 7. There's similarities, right? The 2/9 is a multiplier on both, and the plus 7, is a multiplier. Or not a multiplier, being added. Okay, so who wants to do linear?
I think hard likes to do linear.
One more time. I'm gonna go back. I'll take care of it. Okay. The more, don't move like that.
Okay, well, linear, linear, linear. It's just a line. Where does the 2/9 go?
You grabbed it.
2/9 x.
Oh my. Have you said something that baby?
Or do we need this? Think about it. If we're going to have a shift, let's plug in x equals 0. If I plug in x equals 0 right here, what do I get? Do I shift 7, or do I shift 7 to the left when it's like this? So linear is a little different, right? What happens, oops, I should put this parentheses back in. If we plug in 0 in this, y equals 2/9 times 0 plus 7, plus 2/9 times 7, do we get a negative 7 shifting it to the left? No, because linear doesn't really behave, so there's a difference. Oops, I'm trying to get it back to where it had this. So, linear only actually has a vertical shift. Linear actually only has a vertical shift, so we're not going to write that one with the horizontal shift today. The linear just has an a times x plus the k. The k is our vertical shift. If there's a horizontal shift, it also affects the k. All right, your homework assignment is on the board right there. We have a few that go through all the different functions you know, quadratics, and absolute values with the shifting. Now, this is due next week. Listen, please. Listen, por favor. We have a test next time on circles, ellipses, and hyperbolas. It will be multiple choice. And I will also, I'd like to only say this once. On the test, because it's very formula heavy, I will give you these formulas for ellipses and hyperbolas and circles. And it will be multiple choice. Okay? But you should study. Your first priority is to review your notes and go through examples again. Circles, ellipses, and hyperbolas. This assignment on transformations is due next week. So I would do this after you take the test, so you would study for the test first. Okay? Does that make sense? Study for the test first. Now we have some time, so for the remaining time in class, guys, sit. Either you should be studying circles, ellipses, and hyperbolas, or you should be working on, what's this, what do we call it? The absolute value and families of functions. I would make sure all of your homework on circles, ellipses, and hyperbolas with the focus and directrix, including the parabolas with focus and directrix, make sure those are all done before the test on Thursday. Once again, is anyone not going to be here on Thursday? For some reason you're not, you need to take the test either today or tomorrow, probably